And there you will see very clearly that there are 186 Catholic priests who are involved in the development of science.
Spitzer?
Yes.
Papa C from our church used to tell us that NASA has one of the largest Catholic prayer Bible study groups.
Oh, yeah. There's no question about it. In fact, I was in the space-time theory group at NASA, and three of the guys there were profoundly religious. And so you can see that, 51% of those scientists are really religious people. They believe in God or higher transcendent power. So don't be surprised that, the so-called statistic, that most scientists are atheists is just false, as we said last week. That's right. That's exactly right. Now, yeah, I've been at observatories where half the observatory, literally, were believers in God, and the other half wasn't. We'd have very, really interesting discussions. So sometimes very animated ones. So, but anyway, good. I think I also told you that Richard Dawkins has even come around now because the evidence is so profound for God right now in 20th century physics and science. And you probably know Richard Dawkins, right? He's the atheist. He's the father of the new atheism. And he converted just not converted. He changed his mind from atheism to agnosticism about 10 years ago. And he did it because he claimed that his curiosity trumped his skepticism. Right in the middle of a debate with Archbishop Williams, he decided, he declared, well, I'm no longer an atheist, I'm an agnostic. And Sir Anthony Kenny, who was one of the, he was the moderator of the debate and a very well-known linguistic philosopher in London, said, what? How can you possibly do that? I mean, you're the father of the new atheism. You're turning on your own institution. He goes, yes. So he changed his mind, and there you go. Okay, let's move now to this whole area of cosmology and what's going on there. I'm going to give you a little background first about our universe, and then I want to just get into, a little bit of the history so you get, what some of your students and some of your young adults are dealing with, because they're dealing with things like multiverses and, higher dimensional space universes and string theory and things like that. You don't have to know any of this stuff, but I am just going to talk a little bit about it because I think it might be helpful to when you send some kids to the videos there that you can see on that learning portal. When the kids, see those, they'll understand a lot of the language that I'm going to be talking about. Okay, so what are some factoids about our universe? Number one, our universe is finite, ladies and gentlemen. It is not infinite. I know that some people are under the impression that it's infinite, but it's not. It's quite finite. What are the dimensions of our universe? Just to put it all out there. The first thing is about 5% of our universe is what's called visible matter. About 25% of our universe is dark matter. I know you don't probably know these words or what they mean, but dark matter doesn't radiate anything. It has no forces, no light, no emanation of any kind whatsoever. All dark matter does is form a force of attraction that holds galaxies together and things like that. And then 70% of our universe is what's called dark energy. Dark energy is what makes our universe expand and makes our universe expand at an accelerated rate. So just to give you a sense of what that is. So what about visible matter? What is visible matter made of in our universe? Visible matter basically has four forces. Of course, there's the gravitational force that affects everything. Then there's the strong nuclear force. Then there's the electromagnetic force and the weak force. So there's four forces in our universe, and that's what's causing light and heat and radiation and nuclear energy and so forth and so on in our universe. Now, a visible matter, there's 10 to the 80th baryons. You don't have to remember any of this, but sometimes the kids, they just want to, just show them you're on the same wavelength with them. That, 10 to the 80th baryons, very large number, but very finite number of baryons there. And a baryon is a heavy particle, like a proton or a neutron, something like that, which is a very heavy particle. And so 10 to the 80th baryons, and then if you split that out, it weighs approximately 10 to the 53 kilograms. So the total amount of visible matter in our universe, it's a big number, 10 to the 53 kilograms of mass, total of visible matter. And that's very finite, very finite. How many stars are there in our universe? 10 to the 22. So there's 10 to the 22 stars in our universe, and 10 to the 11th galaxies in our universe. So basically, again, large numbers, but very, very finite in proportion. So, how old is the universe? This statistic is known very, very well. It is 13.8 billion years, plus or minus 100 million years. That's, again, it's a large number, 13.8 billion, but really very finite. And so 13.8 billion years ago, prior to that time, it would be prior to our Big Bang. And so you get the point. Now, why do I bring out all these finite statistics? Because if all of these things, if that's it, if there's nothing beyond our universe, then our universe was created. And everybody gets the implication of that. In other words, God created our universe. So what did physicists do? Ever since Father Lemaitre discovered the Big Bang Theory in 1927, physicists got a little panicky because they didn't want to necessarily, some physicists wanted to believe in creation, some did not. And the ones that did not want to believe in creation put together three alternative possibilities. One was called a multiverse. And I'm going to tell you this just so you get used to this vocabulary. You don't have to remember all this stuff, but the kids that are in school, a lot of them know this stuff. So at least just having some familiarity with it will help. But if you're showing this stuff to the kids, your job is just to facilitate it. You don't have to be a subject matter expert. And you shouldn't be a subject matter, or try to be a subject matter expert, but just to get some familiarity with what's going on. So after 1927, then, you see first the multiverse comes up. And the multiverse is like a gigantic, gigantic universe. And it's kind of coughing out little bubble universes. And of course, hypothetically, there's trillions upon trillions of these bubble universes, one of which is our universe. So that's the multiverse. Now, here's the deal. Even though our universe is only 13.8 billion years old, of course, theoretically, the multiverse could go back infinitely in time. But as we shall see in a moment, that's been disproved. Now there's very, very probably a beginning to any multiverse, and we'll talk about that in a moment. But for a while there, scientists thought, well, I don't have to believe that the universe was created, because maybe the universe came out of a multiverse, and the multiverse goes back infinitely in time. So I don't have to worry about a creation. Hold on to that for a moment. Then there's a second group of physicists that came along, and they basically believed in an oscillating universe, a universe that expanded and then contracted and then re-expanded and recontracted. And so our universe isn't 13.8 billion years ago, because prior to our universe, this is the hypothesis, right? Prior to 13.8 billion years ago, prior to our Big Bang, there could have been lots of expansions and contractions and re-expansions and recontractions. And theoretically, they said, well, those expansions and contractions could go back infinitely in time, so you don't need a creator. Now, today, that has been disproved as well. Today, now, it is very certain you can't have an infinite number of expansions and contractions. You can't go back infinitely in time with a bouncing universe. I'll tell you a little bit about the evidence for that in just a moment. There was a third big area called string theory that you should be aware of. Just to hear the terms is good enough. You don't have to know what it's all about, but just to hear it. So the string theory allows for what we call very esoteric universes. String theory allows for 11-dimensional and 13-dimensional sort of esoteric universes. And within that 13 dimensions, you could have all these bubble universes nucleating out of, continuously on an ongoing basis, so that today we have a virtual infinite number of bubble universes that have nucleated out over an infinite amount of time. Again, today we now know that the string theory, esoteric universes can't go back infinitely in time. They too must have a beginning. But anyway, I bring this out because you'll hear these things where people go, oh no, our universe may be finite in time, but the multiverse doesn't have to be finite in time. Oh, yes, it does. And I'll explain why in a moment. So then the second thing is, people will tell you, oh no, our universe is just, it's in a whole bunch of bouncing cycles, expanding, contracting, and it's just the latest expansion is only 13.8 billion years old, but you could have an infinite number of expansions going back in time. Again, that doesn't hold anymore today either. So you can say, no, you can't have an infinite number of expansions. Even the bouncing universe must have a beginning. And the same thing with the string universe. Now, I'm not going to bore you with all the details. I'm just going to give you some names of some physicists, that I talk about in the videos for the kids. So, for example, one group of physicists who was very active in showing that the string universe, the bouncing universe, and the multiverse had to have a beginning were Arvin Borda, Alexander Vilenkin, and Alan Guth. Now you go, who are these guys? Arvin Borda is an Indian physicist at the University of California, Santa Barbara, who was at the Kavli Institute there. And he got together with Alexander Vilenkin, a Russian physicist who is the director of the Institute of Cosmology at Tufts University in Boston. And those two got together with Alan Guth. Alan Guth has the high chair of cosmology at MIT there in Boston, and he'll probably get actually the Nobel Prize for inflationary theory. But in any case, the main thing to remember, you guys, is that what Borda, Vilenkin, and Guth, and just remember BVG, the BVG proof, or the BVG theorem. The BVG proof shows that the multiverse has to have a beginning, that the bouncing universe has to have a beginning, and that the string theory universe has to have a beginning. And there's a lot to this. I don't want to get into it tonight, but I do explain it a little bit in the videos. That would be video number 2. I'm sorry, not video number 2, video number 3. I explain it, what that's about. So if you're interested in that, or you want some more information on that, just go to the learning portal there, and you can hear it on the video, or you can read it in the book. But just remember now, this one thing: Bordova-Lincoln and Guth, MIT, Tufts, and UCSB. Those 3 physicists show you have to have a beginning of multiverses, string universes, and bouncing universes. Now, why is, before I get into the whole thing of why this is important, there was one group of people that came along just a little bit later, and they, like Leonard Susskind and these guys, who proposed what's called a fractal multiverse. A fractal multiverse. And this fractal multiverse could avoid the consequences of the BVG proof. So it seemed like it could really go back in time infinitely. And then this fractal multiverse, it would not only have been an eternally inflating universe, but also it could have given rise to an infinite number of bubble universes in which there would be no problem explaining order and higher complexity order and so forth, because gosh, anything can happen. If you got an infinite number of bubble universes over an infinite amount of time, anything could happen. Absolutely anything can happen. Now, what happened? How come that fell out too? Why is it that physicists prohibited this infinite fractal multiverse? I'm just going to give you 3 names again. You don't have to remember why all this is the case, but just try and kind of remember who are some of the guys that showed that fractal multiverse couldn't exist. The first thing is there's a theory called the Boltzmann brain theory. And you don't have to remember this either, but it just simply says this. What's a Boltzmann brain? A Boltzmann brain is like your brain, all right? It's going to fluctuate into existence in a thermal vacuum with all of the memories of being in an organic universe like ours. You can laugh all you want, but you know the odds of that happening are 10 raised to the 10 raised to the 50th to 1. So it's really, really improbable that you're going to have, that's a double exponent, right? That's a huge number, 10 raised to the 10 raised to the 50th to 1. And so that you would be, a brain that fluctuated into existence with all your memories of being in an organic universe, just fluctuated into existence by pure chance. So what are the odds of our universe? Our very low entropy, very spacious, very luscious, universe with 10 to the 80th baryons. It is 10 raised to the 10 raised to the 123 to 1 against. Let me repeat that number. It's 10 raised to the 10 raised to the 123 to 1 against. That is the same odds, ladies and gentlemen, of a monkey typing the entire corpus of Shakespeare perfectly by random tapping of the keys in a single try. Now, the great physicist Roger Penrose at Oxford University calculated that, the 10 to the 10 to the 123 to 1. Actually, a very simple calculation, to be honest with you. You just take the number of baryons in the universe, 10 to the 80th, and you multiply it by the entropy per baryon, which is 10 to the 43. So that equals 10 to the 10 to the 123. And then you just take the exponential of it. That's the odds of that happening by pure chance. It's the reverse of the logarithm. So it's 10 raised to the 10 raised to the 123 to 1. Monkey typing Shakespeare perfectly. That's what it is. Now, here is what Penrose said.
Well, if you've got 10 raised to the 10 raised to the 123 to 1 is the odds of our universe happening. But the odds of you being a Boltzmann brain are 10 raised to the 10 raised to the 50th. Guess what? 10 raised to the 10 raised to the 123 minus 10 raised to the 10 raised to the 50th is still 10 to the 10 to the 123. That number, when you deal with double exponents, things are very deceptive, because when you got 10 to the 10 to the 123, that number is so huge. You guys, if you took every zero in that expression, our solar system to its furthest extent and its furthest and its highest volume could not hold that number if every zero were 10-point type. That number is so big that 10 to the 10 to the 50th, large as that number is, barely reduces it at all. 10 to the 10 to the 123, says Pedro's, minus 10 to the 10 to the 50th is 10 to the 10 to the 123. Barely reduces it at all. Well, what does that mean, you guys? We're all Boltzmann brains. That's what it means. But wait a minute, I'm not a Boltzmann brain. And that was the very first time when physicists said, you know what? There is a consequence of an infinite multiverse that we've got to face. That it is an almost absolute certainty that every one of us would be Boltzmann brains that fluctuated into existence in a thermal vacuum, fully loaded with memories of being organic. But we're really not organic life forms living in a universe with 10 to the 80th baryons. Clearly false. The first attack against the infinite multiverse. Second attack against the infinite multiverse was a very famous physicist, one of the founders of string theory, named Thomas Banks. Just remember that name, Tom Banks. He just killed it. He basically, on the basis of theoretical and experimental evidence, showed that eternal inflation and an infinite multiverse was virtually impossible on the basis of experimental physical grounds. Then take a look at these two scientists. Stephen Hawking, remember him? Stephen Hawking and Thomas Hertog, you may not know him, very, very important Belgian physicist. In 2018, this is Stephen's last article that he wrote for the Journal of High Energy Physics before he died. In 2018, he wrote a paper, an article called A Smooth Exit from Eternal Inflation. And this is what Hawking discovered. By the way, I debated Hawking in 2010 on the Larry King show, not debated, but just had an animated discussion with his partners, Leonard Mladenov and Deepak Chopra on the Larry King show. At that time, Hawking really did not believe that there had to be a beginning and a creator. Well, everything changed in 2018. Because Stephen and his partner, Thomas Hertog, Stephen Hawking and his partner, Thomas Hertog, were looking at the data from the gravitational wave detectors called LISA and LIGO. And what they discovered was the following things. And just remember this, because people think Stephen Hawking died, as a kind of agnostic. He did not. This is what he discovered. Number one, by the way, this article is free online. And if you, I've got the, if you want, there's a book I wrote called Science at the Doorstep to God. It's a brand new book. And anybody who wants it, if you want me to bring in some copies of it, I can sign it, but it'll cost you $20 because I can't give away books, too expensive. But the main thing is I've got all the articles cited. So all you have to do is just type in that URL and bingo. You can get the article free of charge from Cambridge University, free, and also from the Journal of High Energy Physics. Now, the main thing to remember is when people tell you, no, there can be an infinite multiverse, just go, And they go, who says? Stephen Hawking. That's the first thing that included. No, he was an agnostic. No, he wasn't. Watch what he showed. Number one, on the basis of the gravitational wave detection and also on the basis of our quantum versus classical physics in our universe, he made the following 4 observations. Number one, first, inflation must have a beginning, and therefore every multiverse must have a beginning. Beginning. I'll explain the significance of that in a moment. Stephen knew the significance of it. Number 2, not only must every multiverse have a beginning, but if there is such a thing as a multiverse, and we certainly haven't proven it, it could only have a very small number of bubble universes. Very small number. Maybe 2,000 bubble universes max. That's going to be important when I talk about fine-tuning in just a moment. Don't get too worried about this stuff. Just know that Stephen Hawking says really put a nail in this coffin of infinite multiverse. Number 3, all of those bubble universes, that small number of bubble universes in a multiverse, would be very similar to our universe. Well, why is this so significant? Let's look at why is a beginning first so significant. A beginning in physics, and I don't know if Vilma's got this. Can you see that stuff on a beginning, Vilma? Yes. Oh, sorry. Good. Now I know where you are. Front row seat. So now take just 3-step argument, and maybe you might be able to remember this for some of your kids. Step number 1. Remember what we're talking about here is physical reality itself. Remember now, it doesn't matter whether physical reality is just our universe, or whether it's a multiverse, or whether it's a string universe, or whether it's a bouncing universe. It doesn't matter. Every one of those configurations needs, according to science, a beginning. You with me? Yeah. Okay, now, if you have to have a beginning of physical reality, whether it's a multiverse, just our universe, whatever, if it has to have a beginning, prior to that beginning, physical reality was nothing. It was literally non-existent. There was no physical reality. There was no space. There was no time. There were no constants. There was no intelligibility of physical constants. There was nothing. Physical reality was nothing. Now, there could be something higher than physical reality, but prior to the beginning, physical reality was nothing. You guys get it? Step number 2. What can nothing do? Nothing. Because it's nothing. That's real clear. Now, don't sneak something into nothing, right? You can't say, right, that space, empty space is nothing. No, you can have more or less of empty space, but you can't have more or less of nothing because it's nothing. Thank you. Very well said. Now, let's go to number 3. If prior to the beginning, physical reality was nothing, and nothing can only do nothing, and here's the rub, then prior to the beginning, when physical reality was nothing, it could not have moved itself from nothing to something. It couldn't have moved itself from nothing to something because when it was nothing, it could only do nothing. Uh-oh. That means that prior to the beginning, when physical reality was nothing, something else, something which transcends physical reality, something which is beyond physical reality itself, that had the power to create ex nihilo, that had the power to create from nothing, that something else must exist and must have moved our physical reality from nothing to something. Ladies and gentlemen, that's what science is saying today. Now let's get back to the huge number of scientists that are zooming over and becoming theists. They're becoming believers in God or a higher transcendent power. Why? It's not just the near-death experiences. It's the cosmos. The cosmos can't explain itself. Hey, when I was debating Stephen Hawking, he didn't believe that a creator was necessary. But then in 2018, it is very clear Stephen Hawking has turned the corner with Hertog, with Banks. I mean, even, I got to tell you, Richard Dawkins, the father of the new atheism, has at least said, yike, I better not make such a quick conclusion. I better take a look here at the possibility. I better, my curiosity is trumping my skepticism. Enough said. Okay, so that's, a very important consequence. If there's a beginning of physical reality, then there's going to have to be a creator that's beyond physical reality.
Spitzer?
Yes.
Thomas Aquinas,
Yes.
when he was talking about that, and he was trying to prove God, he used the motion issue, and he said there had to be somebody who did the first thing. Is that similar?
No, it's a philosophical proof, and it's a legitimate one, right? But it's different because here, what we're actually showing is that physical reality needs a beginning. Aristotle and Thomas Aquinas didn't believe, or they didn't know, that you could establish through evidence that the universe would need a beginning. They thought that was a matter of faith. But today, we have very good evidence that there was not only a beginning of the universe, but also a beginning of the multiverse, if there is one, string universe, physical reality itself. So the reason I point this out, I mean, Thomas Aquinas has a very valid philosophical proof. The kids today, they don't know how to deal with philosophy. They just sort of go, well, okay, that's great. That's interesting. What does science say? This is what science says. And that's what makes it so convincing. Do you sort of get it? They really do put a lot of faith in science, I'll have to say. Isn't that funny? Faith in science. So, okay. Let's now go to just one other approach. I don't want to bore you with too many things. But let's go back to the monkey typing Shakespeare. And these are what are called fine-tuning arguments. Science not only gives us evidence for a beginning, science also gives us evidence that that creator that we were just talking about, that's beyond space and time, that moved physical reality from nothing to something prior to the beginning, that creator is highly, highly intelligent. And we can get a lot of very good information for that. So the first thing is these things are called fine-tuning arguments. And what they mean are fine-tuning for life in our universe. Don't get discouraged if you don't get all this jargon for science. The main thing to remember is there's a ton of evidence there that this creator is very intelligent indeed. So I'll just kind of give you a lay of the land here. And if you want the real specifics, you can go to the videos or you can go to the learning portal and just read the book there, the expanded workbook for the Catholic Faith and Science. Or you get, if you really want the down and dirty, get Science at the Doorstep to God. And it'll have all the details and the equations you could possibly want. Okay, let's just take a look at fine-tuning arguments for a second. Go back to the low entropy stuff for just a second. As a matter of fact, our universe has exceedingly low entropy. In fact, it is so low, as I just told you, that the great physicist Roger Penrose calculated that it would be 10 raised to the 10 raised to the 123 to 1 of this low entropy universe occurring at the Big Bang by pure chance. Like I said, monkey typing the entire corpus of Shakespeare perfectly in random tapping of the keys in a single try. Not gonna happen. But that is, in fact, what we are confronted with. Now, when you are confronted with that, and by the way, you need high order, low entropy like that in our universe to have life. You know what low entropy means? Low entropy means that we have a thing in thermodynamics called order, and order is what allows physical systems to do activity, what we call net macroscopic flows of matter and energy. Essentially, if you don't have low entropy, which means high order, your physical system is going to die soon. And if the physical system dies soon, it will not be able to do anything. It will be what we call a dead system. So this low entropy, it's really necessary in order to have any kind of activity in our universe. And think of the universe as like a wind-up toy, and there's just so much tension in that spring, but you just keep letting the toy move around, and eventually the key will turn around so that all the tension in the spring is released. And think of that tension in the spring as low entropy or high order, and then it's going to die. It's just going to stop. And when it stops, the little toy soldier, the toy car isn't going to do anything anymore unless you wind it up again. But that, of course, is, goes outside the analogy. Okay, so what's my point that's key? The odds of us having our low entropy, our high order, so necessary for life. Because we need activity. We need activity in novas and supernovas and in all the development of the stars and stellar nucleosynthesis and planets. We even need activities for physicists to be busily thinking about it. The point is clear. We need activity. We need low entropy. And yet the low entropy of our universe is the same. The odds of that occurring is the same as a monkey typing the entire corpus of Shakespeare perfectly in random tapping of the keys in a single try. You think about that for a second, you go, well, how? Well, just about 10 years ago, before Hawking got on the scene in 2018, people said, well, you don't have to make recourse to an intelligent creator. I mean, after all, you could have a multiverse with 10 raised to the 10 raised to the 123 bubble universes, in which case there could be a universe like ours by pure chance. And that had to be considered as a very, at least as one possible option that, is at least possible. And so for a long time, people just said, well, don't jump to any conclusions. But look at what Stephen Hawking and Thomas Hertog and Thomas Banks did. Once they put a limit on the number of bubbles in the bubble universe and said most of those bubble universes have to be like our universe, yiko! You got maybe 2,000 bubble universes tops if Hawking is correct. If Hawking is correct, then I'm telling you, 2,000 bubble universes won't do spit to get you out of a 10 raised to the 10 raised to the 123 to 1 odds of getting our low entropy. In other words, there's only one solution left: an intelligent creator. Something which actually intelligently infused that low order into our creation, even when it is so very much against the odds. An intelligence put it there. A transcendent intelligence put it there. That's where we are today. I mean, literally, from the science community point of view. Let's just take a few other of these kinds of cosmic coincidences. There are many of them that you can see in the videos and so forth. A second one is the cosmological constant. Now, in our universe, the cosmological constant determines the exact rate of acceleration of our universe. So it's a complex equation. But the great Steven Weinberg, Nobel Prize winner, calculated what the odds are of getting a life form from our cosmological constant. How fine-tuned must our cosmological constant be? It must be fine-tuned to 1 part in 10 to the 120. What's 10 to the 120? Think of this. It's a trillion, 10 times. A trillion, 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 trillion. I'm not kidding you. That's what it is. So it's 1 part in a trillion, 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 trillion. Do you know that's a monkey typing the first 2 scenes of Macbeth perfectly by random tapping of the keys in a single try? And not gonna happen. Now, what is the deal here? If you get 1 part off, 1 part, off, higher than what the exact amount of the cosmological constant must be, then our universe will expand so rapidly that no galaxies will form, no galactic systems will form, no stars will form, nothing will form. It'll just be a cloud of hydrogen gas. Very bad for life forms. On the other hand, if it were 1 part, up to the bottom, to the lower, then our universe would collapse into a black hole and be literally crushed into 10 to the minus 33 centimeters. You mean we averted complete cosmological disaster by 1 part in a trillion? Yes, we did, higher or lower. 1 little part, and life is impossible. Any kind of life is impossible in our universe. Monkey typing the first 2 scenes of Macbeth perfectly. Again, prior to Hawking and Hertog and Banks, it was thought what? Well, a multiverse could do it. If you had a multiverse with 10 to the 120 bubble universes, a trillion bubble universes, we could get one like ours by pure chance. But now that we have a limit to the number of bubble universes, if Hawking and Hertog are correct, maybe a couple thousand tops, won't come anywhere near a trillion. You know what the most logical and most rational conclusion left is? Again, an intelligent creator. It's now the most reasonable and responsible hypothesis to explain not only our low entropy, but also our cosmological constant. The most reasonable, responsible, rational, from a scientific point of view, explanation. A creator with super smart, intelligence? That's right. I'll give you just a couple. Do you want a couple more for good measure? Okay, we've got 4 forces. Remember our 4 forces in our universe: the gravitational force, the strong nuclear force, the weak force, and the electromagnetic force. Now, each one of those forces has constants associated with it. So the gravitational force has the gravitational force constant. The weak force has the weak force constant. The strong nuclear force has the strong nuclear force coupling constant. And the electromagnetic force has 3 constants associated with it: the mass of the proton, the mass of the electron, and the electromagnetic charge. Okay, I'll give you a couple of examples from the constants, and you'll see, whoa, we keep encountering these problems again and again. Now remember, those constants are specific numbers. There's nothing in our universe that determines, like from the laws of physics. The laws of physics don't determine what that number should be. Nothing. They are just there. We call them free parameters. They could have been just about anything at the Big Bang. However, if they didn't have exactly the numbers that they had at the Big Bang, we'd have no life in our universe. For example, if you take that weak force constant and that gravitational force constant relative to our cosmological constant, you just alter those two constants by only 1 part in 10 to the 50th. That's like a trillion. So if you take 1 part in a trillion, and you go higher than the exact constant for the weak force and gravitational force that we got at the Big Bang, if you go 1 part higher out of a trillion, then our universe would have been continuously exploding violently to this very day. Very bad for life forms. No life form could possibly develop. That's just 1 part. So if they were just a little higher, right, everything would have been literally exploded, away. On the other hand, if it were 1 part lower in a trillion, than the number it just happened to have at the Big Bang, then our universe, bing, would have been in a black hole where all of the mass of the universe would have been collapsed into 10 to the minus 3, 33 centimeters. Teeny little dot. And the whole mass of the universe is there, which incidentally is very bad for life forms. So the point is, you mean we averted complete cosmological disaster for any possible life form in our universe by 1 part in 10 to the 50th, higher or lower in the weak force constant and the gravitational force constant relative to the cosmological constant? Yep, that's what I'm telling you. You know the odds of this happening? Typing the first scene of Macbeth perfectly. Yeah, right, you got it. Okay. It just keeps getting worse. Here's another one. Take those 3 constants associated with the electromagnetic force. By the way, these are very well known in the physics community. So you take those 3 constants for electromagnetic force. That's mass of the proton, mass of the electron, and the electromagnetic charge. If you vary them only 1 part in 10 to the 39th, now that's not 10 to the 50th, but still, it's a trillion and a little bit. So you alter them 1 part in 10 to the 39th. So that's like a decimal point, 38 zeros and a 1. Teeny little fraction, higher or lower than the actual values they had at the Big Bang. Mass of the proton, mass of the electron, electromagnetic charge. Just a teeny little fraction off. Decimal point, 38 zeros and a 1. Then every single star in our universe would either be a blue giant or every star in our universe would be a red dwarf. What is a blue giant? A blue giant is a hugely explosive star that can span literally like maybe a 10th of a galaxy. If every star in our universe were a blue giant, then every single galaxy would be a boiling cauldron of heat higher than anyone can possibly imagine. And you know that what happens to life forms? Very bad for life forms. Alternatively, if you just lowered those 3 constants by just 1 part in 10 to the 39th, then every single star in our universe would be a red dwarf. And red dwarfs have almost no heat whatsoever. Everything is freezing, like the freezing of empties, of outer space without any kind of force in it whatsoever. Which, by the way, is really bad for the development of life forms. I can go on and on and on until you fall asleep. But the main thing to remember is simply this. We live in an incredibly well-designed universe. And up to the time of Hawking and Hertog, there were two possible options for explaining how you could get these free parameters to have the exact value that they need to have within, like, a 1 part in 10 to the 39, 1 part in 10 to the 50, 1 part in 10 to the 120, trillion, right? I mean, so you only had two choices: a really huge multiverse, or you could have an intelligent creator. If you take Hawking and Hertog seriously, and you can only have a small number of bubble universes, most of which are like our own, then the creator, the intelligent, transcendent creator hypothesis is the most reasonable and responsible hypothesis on the basis of contemporary scientific evidence. Just saying. Here is the deal. I'm going to give you two quotes just for by the way, I forgot to give you Alexander Vilenkin's quote about the beginning of the universe, but too late now. I'll just confuse you. But let's just take Fred Hoyle's quote. Fred Hoyle, I'm telling you, he's the father of stellar nucleosynthesis, so he ain't no dummy. Now, Fred Hoyle, he basically was the atheistic gadfly in the physics community. I'm not kidding you, for decades and decades, like 3-4 decades. I mean, every time somebody came up with a theistic hypothesis, belief in God, there was Fred, to always guarantee the rights of atheism. So he'd always think of something else to redress it. Well, Fred Hoyle redressed himself. I mean, he totally changed his mind, turned 180, did a Stephen Hawking, except even more radically, because Stephen was an agnostic, but he wasn't an atheist, whereas Fred was really a radical atheist. So one day his partner, Fred, Fowler, came in and he says, Fred, I just was looking at the resonance levels of beryllium, oxygen, carbon, and helium. And you know what the odds of having an abundance of carbon by pure chance in our universe is? And it tells him this immense number. And so, of course, Hoyle goes into his study. This, I don't know if this is apocryphal or not, but he definitely came out and he had changed his mind. And this is his quote. He came out later and said, at the odds of us having an abundance of carbon is the building block of life, right? So really necessary for life in our universe. The odds of us having an abundance of carbon in our universe by pure chance is the same as a tornado sweeping through a junkyard, assembling a Boeing 747 ready for flight. That is small odds. Then he came out, and in the Caltech Journal, which one time had probably been a voice of secularism, he came out and said this, and I think it's there on the screen. He basically said, I don't think that there are any blind forces worth speaking about in our universe. It seems to me that there must be some super calculating intellect that has monkeyed with the constants of physics and those of chemistry and biology as well. I consider this conclusion to be beyond the shadow of a doubt. Get it? In other words, he not only changed, he did a 180 and literally said, I believe in God. I believe in this super calculating, super intellect that is, a transcendent intelligence or transcendent creator. And so you can see why we're looking today at so many scientists moving into the area of belief in God. And the doctors, of course, they see the near-death experiences in hydrocephalic patients, intelligence, and things like that. The cosmologists are also getting the same dunking in there. I'm just going to give you one last quote, and then we can move on to Jesus and the Shroud of Turin. Yeah. Okay, so let me just give you this one quote. We're going to take our break, and then we're going to get right into the shroud. So maybe only a 5-minute break because I don't want to keep you too going over. Here is the thought. This comes from Dr. Robert Jastrow. He's the founding director of NASA's Goddard Institute for Space Studies. This is what he said. He said, scientists unshackled themselves from the domain of superstition and took on a scientific methodology, which was fastened, in its place by empirical observation, by mathematics and rigorous measurement. With this methodology, they began to scale the heights of knowledge, came to the final precipice, pulled themselves over, and found a band of theologians there awaiting them for centuries. Okay, so that's a nice little quote to talk about. And I have it in those videos for the kids, that you can show them. But I'm telling you, things ain't what they used to be in the world of science and in the world of cosmology in particular. And the people you might have least expected to be the great heralds of theism, Fred Hoyle, Stephen Hawking, Thomas Hertog, are now the heralds of it. And as I said, even Richard Dawkins has come off his God Delusion website, his spaghetti monster God, and has finally declared that he's moved toward agnosticism because there's so much data out there. His curiosity has trumped his skepticism. Okay, well, come on back if you could in 5-6 minutes. And then I really want to get into this shroud material because it really will jaw drop the kids. It'll really jaw drop your parishioners if you do the parish program. Heavenly Father, again, we give you thanks for your many blessings to us. We ask you to send your Holy Spirit down upon us now to inspire, guide, and protect us, so that we might see your hand lovingly and intelligently creating our universe, and beyond that, in your Son's death and resurrection, manifest through science. We ask this through Christ our Lord. Amen. Mary, seat of wisdom, pray for us. Father and Son and Holy Spirit. Amen. Okay, we're now going to move into the area of Jesus. And believe it or not, science has a very good impact in the area of Jesus too. I'm not going to go over the historical evidence for Jesus, but I just want to cover 3 points very briefly. We have 3 sources for Jesus outside of our New Testament scriptures. Number 1, we have, and they're all hostile sources. And they're all from the 1st century. And that's great. We have the Roman historian, Cornelius Tacitus, who not only tells us of the existence of Jesus, but tells us also that Jesus was crucified under the procurator Pontius Pilate during the reign of Tiberius. So that's as clear as a bell. Why would a Roman historian, who is very hostile to Christianity, ever give that testimony unless it were true? So, secondly, we have a Jewish historian by the name of Flavius Josephus. Flavius Josephus, again, is a 1st century Jewish historian writing for the Romans. Can somebody shut that door? No, thanks. Writing for the Romans. And so what we want to do then is just look at what his testimony is. 4 different things. Jesus was known to be a wise man. Number 2, he performed miracles. And this is our first testimony outside of the scriptures that Jesus was performing miracles from a hostile Jewish source. Thirdly, then we get the testimony that Jesus was crucified under the procurator Pontius Pilate. Then we have the Babylonian Talmud, and the Babylonian Talmud is very anti-Christian and says that Jesus was a sorcerer And because that's how he did his miracles, right? He did his miracles through sorcery. And because of his sorcery, that is the reason that he was taken out and crucified. Okay, so you get the point. Is, if a student comes up and says, oh, well, the church just made this up. The only place we're going to get this information is from the New Testament. That's just not true. You got 3 very hostile witnesses, contemporary to Jesus, a Roman, a Jewish historian writing for the Romans, and the Jewish Talmud itself. Okay, let's just go now to the Shroud of Turin. What is the shroud? The shroud is a linen cloth, 14 feet long by 3.5 feet wide. That shroud contains an image of a man, and we'll talk about that image in a moment. And there are 372 bloodstains on that image. The bloodstains and the image give us a picture of a crucifixion closely resembling the unique crucifixion of Jesus as we are told of it in the scriptures. So that's the first thing to remember. So the bloodstains, 372 of them, that's a lot. And they correlate perfectly with anatomically with the body and tells us of the crucifixion, the specific unique crucifixion of Jesus. The fourth area of importance, it's the most scientifically tested historical artifact in all history. So there's never been any historical artifact that has undergone 132 scientific tests. Just the Shroud of Turin. And next, it is the most unique image in the history of images. There's nothing else like it. And you'll see why. I'll tell you why. Because emblazoned in that image is a perfect 3-dimensional, I mean inside the body and the surface of the body. So there's imaging of the backbone inside the body relative to the flesh surrounding the backbone and so forth. So you can see inside and outside along the surface of the body. It's a perfect 3-dimensional photographic negative image. Photographic negative. It's not a positive image. It is really a photographic negative image that's emblazoned on a non-photographically sensitive linen cloth. So that is the strange, curious feature of the Shroud of Turin. As I said, in 1978, a huge number of tests were performed on the shroud, which I'll be describing momentarily. But it was determined that the preponderance of evidence was almost, certainly pointing to the shroud being the authentic burial cloth of Jesus. Then in 1988, everything changed. A C14 dating, a carbon dating, was done in 1988, where a sample was taken from a very controversial part of the shroud, a controversial corner. And I got to end this popcorn because I'm going to have crunching throughout my entire lecture.
I'm working on the video, Father.
Pardon?
I'm working on the video.
Yeah, just pause 1 second.
Where's the mouse? You can't get it to advance the photo.
Oh, I see. Oh, that gives me time for popcorn.
No pressure, Don.
Did,
There goes the popcorn. Sorry, Mom.
Breaks over, Father. Drink some water.
okay. So what we noticed is that a sample was taken from this very controversial corner of the crowd, of the shroud. And because that corner was burned during the fire of Chambéry in 1530, then some sisters came and sewed that up with what's called invisible mending method. But they used not linen fibers from which the shroud was made, but rather cotton fibers that were dyed to look the color of the linen shroud. Now that happened in the 1530s. That's where they took the sample to be dated from. Now, of course, just doing that already makes the dating test pretty suspect. So, or as my students would say, sus. So the main thing is, the key thing is, what we're dealing with then is this 1988 carbon dating, where basically the dating showed that the shroud came from between 1250 to 1360 or so AD. Well, that surely couldn't have been then the burial shroud of Jesus Christ, because that would mean the shroud's only 700 years old. And of course, that's a far cry from 2,000 years old. So it looked for a second there in 1988 like the shroud was going to be debunked, but indeed it was not debunked. In fact, the 1988 carbon dating was what was debunked. So let's take a look at what happened. How come the carbon dating got debunked and the shroud is now back to a first century origin? First, Ray Rogers, Dr. Ray Rogers, who was a thermochemist, determined, he looked at all these sticky tapes from the region in which that sample was taken for the carbon dating. And he found in those samples cotton fibers that were dyed with a gum dye mordant that was only available in the Middle Ages. Immediately, Rogers proclaimed that sample was contaminated with later fibers that, of course, very much altered the dating. So that was the first thing, and that happened. Ray Rogers published that 10 years after the 1988 carbon dating in 1998. Then Dr. Tristan Casabianca and his colleagues in 2018, we're talking 30 years after the 1988 carbon dating, 30 years. They had applied and applied and applied to the British Museum, which held the raw data from that carbon dating, to try and analyze whether it was homogeneous or whether there was heterogeneity in it. So if there's heterogeneity in it, that meant clearly that the shroud, that the sample would have had different fibers from different eras and ages blended together. So finally, in 2018, 30 years later, under a Freedom of Information request, the British Museum gave up the raw data from the carbon dating. There was so much heterogeneity, so much variegation, and so much stratification in those tests, in those samples, that Casabianca and his crew, by the way, they published this in Archaeometry, which is Oxford's big journal of archaeology, right? They published in Archaeometry and basically said no possible way could the 1988 carbon dating have, given a medieval dating with any kind of accuracy. It's impossible. Too much heterogeneity. Okay, hanging in there. Number 3, Giulio Fonti, a physicist at the Italian National Labs, and several of his colleagues put together 3 different tests. These are new dating tests: a Fourier transformed infrared spectroscopy, a Raman laser, you don't have to remember this, a Raman laser spectroscopy, a mechanical tension and compressibility test. And then they weighted them according to the effects that a fire, like the fire of Chambéry, would have. They weighted each one of those tests according to how much carbon would have affected it or thrown it off. When that was done, the 3 tests showed that the shroud originated in 90 AD, plus or minus 200 years, with a 95% confidence level. That's not 700 years ago. In other words, the new dating test whose effects could measure, the results of carbon alterations. They gave a reading of 90 AD, plus or minus 200 years. Then finally, the wide-angle X-ray scattering test. This was a very significant peer-reviewed test. That peer-reviewed test, it was peer-reviewed over 3 years in the best physics journals and optics journals. When the tests were done on the Shroud of Turin, they said that the shroud should be dated to between 54 to 75 AD. That's in spitting distance to 33 AD. In other words, mid-first century is the time that most definitely describes it. We also know from a variety of other, that same wide-angle X-ray scattering test is not affected by carbon residue. It's based on what's called the ambient secular temperature in which the shroud's being stored. That is what causes the enzyme breakdowns that are measurable by wide-angle X-ray scattering. The main thing to remember, though, is if the shroud was only 700 years old, as the carbon dating said, then the ambient secular temperature in which the shroud would have to be stored, according to wide-angle X-ray scattering, would have to be higher than the highest temperatures on the Earth. And the shroud would have to be stored in those super high temperatures day and night throughout the entire 700 years of its existence. I don't think so. That carbon dating, is definitely flawed. Okay, well, let's go then to where did the shroud originate? There are pollen fossils and grains embedded in the shroud, and these can be very definitively identified. And the Swiss criminologist Max Frey was the first to do so. Now there's a whole bunch of guys, 24 of them or something, that have worked with the pollen fossils and grains in the Shroud of Turin. Guess what? Almost 3/4, well over 2/3 of the pollen grains and fossils embedded in the shroud are from Jerusalem and northern Judea. Hey, it couldn't have just been in Liry, France, and Turin, Italy, throughout a 700-year existence. In order to get that proliferation of 2/3 to 3/4 of the pollen grains embedded, that shroud would have had to have been in the open air in northern Judea and Jerusalem for 3 or 4 centuries. Now, you look at that and you go, well, what does that mean? It was in Jerusalem. That's probably its place of origin. By the way, 14 of the grains are indigenous to that region, and 4 of them have never been found anywhere beyond northern Judea. Okie doke. So pretty highly probable. The second proliferation of grains comes from Edessa, Turkey. So it had to go to Edessa. And then finally, Constantinople, Turkey. And I can answer any questions about the of the shroud. And the last number of pollen grains and fossils come from Liry, France, and Turin, Italy. Okay. So,
Which slide are you on, Father?
Pardon?
What slide do you want?
Oh, just go to the blood one.
That one? The blood on the shroud or
Pardon?
the blood on the shroud?
The blood on the shroud.
No, probably that one.
Just go there. You okay?
Yes.
Okay. Sorry. Okay. Let's take a look then. Just in sum, where did the shroud come from? It came from northern Judea and Jerusalem. When did it come from? Mid-first century. Perfectly consistent with Jesus. Now let's take a look at the blood stains. As I said earlier, there are 372 blood stains on the shroud. What does that mean? Well, of that 372, every single one of them is not fragmented, segmented, or smeared, which is crazy. How would they get, we'll talk about this later, how can you get the body out? Secondly, every one of those blood stains has AB blood type. Paints, dyes, and rubs, they don't have blood type. Secondly, Every one of those blood stains has human immunoglobulins in it, has human bilirubin in it, has human whole blood in it, has human hemoglobin in it, and so forth and so on. So obviously, these are the human blood of a man with AB blood type. Enough said. Okay, what else does the blood tell us? 3 important things. There is a mixture of creatinine and ferritin in all those blood stains. What is creatinine and ferritin? They synthesize together during a polytrauma, and that's the only time. In fact, they synthesize only during a heavy polytrauma. So in other words, that man is leaving behind 372 blood stains which say, I've been tortured significantly. That is manifest in the blood. Number 2, you'll notice in the blood that the serum plasma separation, so you know how the serum separates from the plasma, that the serum plasma separation is oriented on the vertical axis. In other words, the man was vertically hanging there for quite some time. And we can see that very clearly, again, resembling Jesus's crucifixion, right, that he's hanging on the cross. Thirdly, the blood went on the shroud before the image. How do we know that? Because the image is produced by friability. We'll talk about how that got produced. In other words, the cloth turns crispy. And you can use x-rays and you can see underneath the blood that there is no crispiness. There's no friability of the cloth under the blood stains. So the blood went first, then came the image later. Now, can you imagine a medieval forger doing this? And he's going to put 372 blood stains on a cloth and then put the image on it and get perfect anatomical correspondence? In the Middle Ages? I don't think so. That's just an impossibility. All right, just rest my case right there. So what is this substance? Blood, period. Now, I'm going to talk about the formation of the image in just a minute. Let's take a look at the picture that we have of the passion of this man on the cloth. And I will tell you, it resembles the unique crucifixion of Jesus as the gospel writers portrayed it, almost exactly. First, the crown of thorns. In the entire history of crucifixions that we have, and it is an extensive one, the entire history of crucifixions, we don't have but one crucifixion with a crown of thorns, and that is Jesus Christ. This crown of thorns was weaved with what's called a Syrian Christ thorn, a thorn which is particular to the region of Syria, Jerusalem, northern Judea, the region in which Jesus was crucified. Then you look at the crown. The crown is on the top of the head as well as around the crown of the head. Now, this would never have been expected by a medieval forger. We can assume that the reason the Romans did it was to keep the crown together, because it was made of thorns, and also to plunk it right on the top of the skull, where there would be additional pain for the man who was wearing it. But as I said, Jesus is the only one we know that had such a crown, and the fact that this is made of a Syrian Christ thorn is an interesting datum. All right, number 2, that spear wound that's in the guy's right side, that's in the man's right side. You can see that that spear wound is going right between the 5th and the 6th rib. It's going up at about a 30-degree angle, and it's going to nick the heart. And by the way, the spear is an elliptical spearhead, just like the Roman legionnaires used to carry. It's going to go up at that 30-degree angle. It's going to proceed into the thoracic cavity. It's going to nick the heart, and then it's going to keep going upward toward the pleural cavity, around the lung. And of course, it's the pleural cavity has been filling up with tons and tons of pleural fluid. And the reason that it is because the man's been trying to lift himself in order to breathe. And so his pleural sac is filling up with this clear liquid. And then when the spear hits it, it squirts out. But you know, if you look at the actual chronology of events, the spear first nicks the heart and the blood will squirt out. Then it will hit the pleural cavity and then the clear liquid will come out. Now, if you look at that spear wound on the right side of the man on the cloth, you can see very clearly there's blood in the center, and then around it you can see the clear pleural fluid there that is surrounding it and dried. Now, remember John's gospel, right? The soldiers thrust the lance into Jesus, and out flowed, says John, blood and water. Well, he saw the clear pleural fluid and he said, that's water. And he insists that it is true. I saw it. He is a witness and he knows that his witness is true. He saw it. So he's actually testifying to this, because it's so unusual to have this clear fluid coming out of the side of the man. Yet we see exactly that that's what did come out of the man. And by the way, Dr. Frederick Zugabe did a fantastic study on this, which you can get in 2 of his books. But I digress. Now let's go to, again, corresponding to the unusual crucifixion of Jesus, right? When did the Romans ever thrust a spear into anybody? Romans didn't want to end anybody's misery early. But what they did with Jesus is they came to him, says the scriptures, he was already dead. And just to make sure, they thrust the spear in them so that the bodies could be taken off the cross before Passover. That makes sense. That's the record we have from the Gospels that explains the bizarre feature of the spear wound. Let's go to the flogging itself, the whipping itself. A medieval forger would have absolutely thought that the whip used was a single-thonged whip. But that is not what is used. What's portrayed is a 3-thonged whip called a Roman flagrum. And we have, from Herculaneum and from, other, big excavations like Pompeii, we can see that the Roman flagrum had 3 thongs. And we can see that there are these little lead dumbbells at the end of each of the thongs, so that there's a soldier to the right and a soldier to the left, and they're whipping Jesus. They're whipping the man in the shroud alternatively. So first the left, then the right, then the left, then the right, and as they're going through, that whip is coming right around to the side and also to just the front abdominal area of the man. And then as the dumbbells embed themselves there so that when the soldiers yank it back, it shreds his flesh on the side, on the back, and they're going all the way from the top of the shoulders all the way down to the ankles. They are shredding him. And basically, he is losing so much blood that it's little wonder that he dies in 3 hours on the cross. I mean, in other words, the blood loss was so significant. The man was weakened from all the blood loss of having his back and his thighs and his ankles and so forth just shredded, of course, he's only going to last 3 hours. And that explains something very unusual. Why would Jesus have died so early? That whipping, that scourging was really intolerable. Now you look at it and you just say, well, he was, whipped basically 37 times. And with those three thongs, you can tell this is a huge number of stripes that are there that have just shredded his flesh. Let's take a look also, by the way, that, in Jesus' crucifixion, Pontius Pilate wants to avoid the capital punishment, right? He wants to avoid killing Jesus. And so he thinks by whipping him in this horribly, bloodletting way, that it'll be so disgusting, people just say, let him go. But they don't. They want Barabbas instead. Okay, now let's go to the third thing. There's a 11 degree to 15 degree slope in the right shoulder of the man. And on top of that slope of the shoulder, you can see a very large contusion that's kind of popping up there in the middle. Now, the 11 to 15 degree slope in the man's shoulder is no doubt caused because of a dislocation of the shoulder. He didn't break his bone. It wasn't a separation, but the 11 to 15 degrees indicates pretty much a dislocated shoulder. And you can see that the dislocated shoulder stretches his arm out. So it looks unnaturally long, his arm, because, of course, he has no muscle that is pushing the shoulder up. So the arm looks unnaturally long. That's what we see definitely in the shroud. We can also see that there are very large scars on the knee of both knees of the man. So we can kind of put together what happened that caused the dislocation of the shoulders and the contusion in the middle there. Basically, the man is walking along and he trips. He's weak. And so he trips. And when he trips, there's no way to brace his fall. So he basically goes blam right onto his knees. And then when he hits the ground, causing those scars on his knees, the beam that he's carrying flies up in the air and bam, it just falls right down on his shoulder. That, of course, dislocates his shoulder, causes the contusion. His neck jerks to the left, and his right eye is sucked into its orbit. So just like that, he's kind of incapacitated because his right side will then become paralyzed, at which point they're going to have to find some help for the man, because clearly if his right side is partially paralyzed, there's no way he can carry this cross any further. He can walk, but he has no capacity to carry anything on his shoulder. Now, we always wondered, right? Why was the Cyrenian, Simon of Cyrene, why was he recruited? The Romans never would have done anything to help anybody who was carrying a cross. I mean, just would relieve him of torture. So what's the reason? The man couldn't do it for himself. That's the reason. And of course, he's got a dislocated sort of partial paralysis, and his neck is so jerked violently to the left from what has happened that basically he's almost, I'll just say, a basket case. That's exactly what he is. Now, let's just take a look at the wound on his hand and his feet. We don't have a complete picture here. We only have one nail wound that we can judge. It's the left hand nail wound because the left hand is on top of the right hand in the shroud. Now, you can only see the exit wound that's coming out here in this Z complex of nerves right here in the wrist. So we can see that the exit wound, we can see that there is a 12-degree angle from which the nail is proceeding. So it's not coming out straight. Pierre Barbet thought that the nail went right through his wrist to fasten the hand to the cross. But in point of fact, you can see from the angle that the shroud goes into the palm. The nail goes into the palm. And you see this region here when you curve when you put your hand together. This is called the thenar furrow. And so you can tell that what the Romans did was they pounded the nail in right here in the middle, and then it follows the thenar furrow. There's a cavity under the thenar furrow, and the nail just follows naturally the cavity, coming right out here onto the to the Z complex there in the wrist. And this is a whole very, very an area filled with nerves. So, being nailed like that and affixed to the cross like that. And the man, remember, he has to lift himself up in order to breathe. Every time he does, it's like shocks are going through his whole body because these nerves are going nutso as he's trying to pull himself up to breathe every single time. The same thing holds true with the feet. The feet were not put onto a little ledge that you sometimes see in some of our crucifixes, where you have a little piece of wood sticking out, and the guy can actually, pushes himself up by this little piece of wood sticking out of the cross. Instead, it seems very clear that the feet are put up against the vertical beam of the cross and hammered in flat, so that when the guy, it's almost just above the ankle there, and when it's hammered in, going right through the heel to fasten it to the vertical beam, every time that guy is trying to push himself up, it's not just his hands that are reacting. He is getting, horribly shocked from his feet as well. So this is a portrayal of the man on the cross. It, as I said, a medieval forger would be incapable of doing this with such anatomical precision. Even a medical student today couldn't do it. You'd really have to be exceedingly knowledgeable to put this thing together in such an anatomically perfect way, the blood to the image, to portray the very unique crucifixion of Jesus. Jesus' crucifixion, the history of crucifixions, is unique because of the spear wound, unique because of the crown of thorns, unique because of the excessive number of whippings that have been done, and so forth and so on. Is everybody okay? Do you sort of get the thing? What does it all portend? The shroud validates the historicity, the accuracy of the gospel passion narratives, and the gospel passion narratives in turn validate the actual authenticity of the shroud. So that's, can you manage just one more thing about the resurrection and the image formation? Are you hanging in?
Yeah.
Okay. Okay, you go a little over, but not much. Okay. Yes? Oh, sorry. So the main thing then is, let's go to the image formation. You'll notice that the image is literally, as it were, lying on the very uppermost fibrils of the cloth. So in other words, the image never penetrates to the medulla of the fiber. So it never goes into the middle of the threads and the fibers, and it certainly never goes into the middle of the cloth. It's just hanging there on the very uppermost surface of the fibrils. What does that mean? It couldn't have been produced by liquids. Liquids would have immediately penetrated into the middle of the fibers and into the middle of the cloth. It couldn't have been vapors. Vapors would have absolutely penetrated in the middle of the fibers and into the middle of the cloth. And plus vapors, they would never have given you a precise photographic negative image. I mean, vapors are very amorphous, right? And they just, they can stray over into all the threads that are adjacent to it. And by the way, liquids can also go right through the threads and spangle into the adjacent threads, and you get the point. I mean, it would have been a very blurry and certainly not a perfect three-dimensional photographic negative image. Okay. So that rules out liquids and vapors. There's how about scorching, or something of that nature? Scorching's totally ruled out, because there's a fluorescing test that manifests scorching very, very clearly, and this image has none of that fluorescing in it that would indicate any kind of scorching. So basically, when you eliminate practically every other physical cause, there's only one cause left, and that is radiation, radiation, radiation. That's the only thing that can do it. Radiation acts at a distance, so the cloth doesn't have to touch all the parts of the surface of the body. Moreover, since the cloth is imaging the inside of the body, like the backbone and the bones inside the hands and so forth and so on, since there's imaging from the inside of the body, as well as images from the surface of the body, radiation is the only possible explanation for this. I'm just going to skip to the chase here. There are 42 enigmas on the shroud. All 42 of them are explained by what's called the particle radiation hypothesis. Only 22 of them are explained by what's called the ultraviolet radiation hypothesis. I'll just give you both hypotheses just in case you want to know it. There are two kinds of radiation that can produce the image on the shroud. The ultraviolet radiation hypothesis was the first one to be hypothesis. That was by Dr. John Jackson and his colleagues over at Los Alamos Laboratories here in the United States. A very excellent theory. It was validated to be able to produce an image like that on the Shroud of Turin on cloths with the same spectral reflectance as the shroud. This was done by Paolo Di Lazzaro and his team at the National Italian Labs in 2010. Now, what does that require? That requires that this dead body that was inside the shroud produce, get this, 6 to 8 billion with a B, billion watts of light energy. Now, dead corpses don't ordinarily emanate 6 to 8 billion watts of light energy, which is tantamount to 100,000 to 200,000 searchlights worth of light energy. That's weird. That's a miracle. And more than that, it's not just that, but of course, this could have only lasted for 1/40 billionth of a second, because if it lasted 1 billionth of a second longer, it would have snuffed, that light would have been, can you imagine 100 to 200,000 searchlights worth of light energy coming out at once? It'd been so hot, it would have literally evaporated the shroud. Well, 1/40 billionth of a second. Paolo Di Lazzaro did it. He did it with ARF excimer lasers, but he also said in order to produce an image like the shroud, it would take 14,000 ARF excimer lasers, which is more than all the ultraviolet capacity we have in every single laboratory in the world today. The medieval origin hypothesis isn't going to stand this. It would be a miracle. But that only explains 21 to 22 enigmas. There are 42 enigmas on the shroud. And this is, can I just explain the particle radiation hypothesis? Okay, just take a couple minutes more. The particle radiation hypothesis is the one that is to be preferred. In other words, that explains all 42 enigmas on the shroud. What happened was sometime between let's say 36 to 48 hours after the body had gotten the blood, the shroud had gotten the blood imprints on it from the body, sometime in that zone, the entire body disintegrated in what we call a low temperature nuclear reaction. That is to say, every single particle, stable atomic nucleus in that body underwent disintegration simultaneously. Do you know how many stable atomic particles there are in a body the size of the man's in the shroud? About 5'10" to 5'11". 7 octillion. Again, trillion. Okay, can you imagine all of them undergoing nuclear disintegration at the same time? If that happened, that would be even more of a miracle than the 6 to 8 billion watts coming out of a dead corpse. Whatever the case may be, this is what seems to have happened. If there was a low temperature nuclear reaction coming from the simultaneous disintegration of every stable atomic nucleus, the first thing that would have emanated is a bright light and a boom at the same time as the bright light. And then, of course, like a very split second later, you would see two big, huge flows of particles, what we call heavy charged particles like protons and deuterons, and then neutral particles like neutrons. Okay, these flows of particles, like gazillions of 7 octillion, more than 7 octillion, are just blowing off the whole body. And what are they doing? They're creating the image on the cloth. Why? Because those heavy charged particles like protons and deuterons, they come zooming up and they interact with the electrons, the electrical charges in the fibers in the cloth. And so those protons and deuterons, bam, they stop. Where? At the uppermost surface of the fibrils. That's exactly where the friability is. That's exactly where the image is. That's exactly where the crispiness is. Right there. And of course, do protons and deuterons traveling at high velocity create that crispiness in the cloth with such precision that it turns out to be a perfect three-dimensional photographic negative image? Yes. That was proven by Dr. Kitty Little at Harwell Labs in London, Dr. Jean-Baptiste Renaudot in the Institut Physique in Paris, and by Dr. Arthur Lind here in the United States. So basically, they show this will definitely produce. Do you get what's going on here? Literally, Jesus's own body, the particles in his own body are embedding themselves in that cloth, sticking at the uppermost surface of the image we're looking at comes from the particles that constituted his body. It's not just the blood we have. His whole body is left behind, as it were, his physical body. Not, of course, the body which is underlying his spiritual and glorified body that we read about in the resurrection. But at the very moment, Jesus' body is moving from a physical body to a spiritual body. He's just leaving behind this remnant as a relic, the particles that constitute his own body, and they're making this image. Yeah, let me just tell you 4 things, and I'll end it. We always wondered, how could anybody, like the apostles or anybody, let's suppose that Jesus did not rise from the dead and so forth, but his apostles stole the body. Now, I'm not saying this at all, but let's suppose they did. How would they get that cloth off? The only thing they could do is pull the cloth off the body. But all those blood stains, right, that are sitting there between the body and the cloth, when you pulled that thing off by any mechanical or human means, it would have smeared, bleared, and fragmented and segmented every one of those blood stains. Yet not one of those 372 blood stains is fragmented, segmented, or smeared. How? Well, it couldn't have been that the apostles sure didn't steal the body and take the cloth off. That's for sure. But if the body disappeared right out from under, leaving the blood right there on the shroud, that stuck to the shroud, and anything that was on the body disappears along with the rest of the body. Get what I mean? We got an explanation here, finally. We always wondered why all 372 of those bloodstains on that shroud were bright red. I know some of you who are police officers, you know what happens. When you start off with bright red bloodstains, but then that turns to, a darner, and then to brown, and then to black. So all those bloodstains, all 372 ought to be black. They certainly shouldn't be bright red. How would that happen? Remember those neutrons? Neutrons don't stop at the uppermost surface of the fibrils and cause the image. Neutrons go zooming through, right? They don't have any charge. So they're not interacting with the charges in the cloth. They just zoom right through the cloth, and they zoom right through the body. But they're moving so fast, they irradiate the blood. Now, if you take neutron irradiation in that blood, and this has been shown 100 times, you irradiate that blood with neutrons passing through it, and then you hang it out in an exhibition where there's all kinds of ultraviolet light. What does it do to all the blood stains? Turns all those black blood stains into bright red blood stains. Exactly. This has been done by Goldoni. It's been done by a whole bunch of other physicists and biochemists. Okay, just 2 other things that are fascinating. Remember I said that you got the imaging from the inside of the body as well as the surface of the body on the shroud? Well, you take this explanation of the particle radiation hypothesis. You take this for just one moment. What's happening here? You can see that as the shroud is formed, right? Just imagine in your mind's eye for just a second. Just think of this. All of the particles are going to disintegrate simultaneously. So the ones that are on the surface of the body, then the next layer and the next layer, and they're all doing it simultaneously. But it takes just a little split second for the ones underneath the surface to reach the surface. So the ones that are on the surface are already gone, hitting the cloth. Whereas the next one take a split second, but they can now go through. The pathway is clear. And then the next one, then finally you get to the bone, and the bone ones then are coming up, and the path is clear for them. All the other ones have already made their escape. It took a split second for the bone ones to get to the next layer, the next layer, the next layer, the next layer. And of course, the pathway is completely clear from them. You have perfect three-dimensional imaging. Has this been, Dr. Kitty Little at Harwell did it. I mean, it is very clear that this is exactly what can happen. Furthermore, just do a couple more things, and you can get the point. We always wondered why the frontal image and the dorsal image, the back of the shroud and the front of the shroud, we always wondered how could it have the same intensity of image? Because that body with all that gravity is sitting right down on the dorsal image, which should be darker and more precise because the body is closer to it, etc. How come the frontal image is the same intensity? Well, in a nuclear reaction, you guys, a vacuum is created. And if a vacuum is created, it pulls both of the sides, the dorsal and the frontal part of the cloth, toward the center at equal intensities. Just saying. And on top of that, by the way, you want to know another reason why the C14 test will never work? Because if you've got neutrons that are zooming through that cloth, I'm telling you, those neutrons will turn, a linen cloth is made of cellulose, and cellulose is filled with N14. Nitrogen 14. You irradiate nitrogen 14 with neutrons, guess what? It turns into C14, the very substance measured by the carbon dating. No wonder there's an excess of carbon 14 everywhere on the shroud. Just absolutely last thing. We always wondered how come the shroud was so tough. It lasted so long. It shows almost no signs of age. It looks like, it's resistant to solvents, resistant to water, resistant to age. How is that possible? You take those neutrons that are passing through the cloth, they're breaking down all the linear carbonyl structures in the linen, right? But when the linear carbonyl bonds are broken, they reconstitute themselves as crystalline carbonyl bonds. Well, what does that mean? Much stronger. Explaining why, first of all, there's such a proliferation of crystalline carbonyl bonds in the shroud, and why it is so tough and resolved. Anyway, I just leave you with this thought. By the way, there's a confirmation point too with the particle radiation hypothesis. If this was a low temperature nuclear reaction, you can expect to find an abundance of what's called cosmogenic isotopes in the shroud, like chlorine 36 and calcium 41. These are only found near places with atomic nuclear events, like nuclear reactions, or some in the galaxies by supernovas, et cetera, et cetera. The main thing to remember, though, is you find that in the next shroud investigation, you mark my words, every physicist of that shroud investigation team, every one of them is going to be looking for these cosmogenic isotopes. And if they find an abundance of cosmogenic isotopes, it will be certain that this came from a low temperature nuclear reaction. It came from the simultaneous disintegration of every single stable atomic nucleus in that body at the same time. I mean, what we're talking about, what Jesus has left us a relic of, is literally this. Number one, the transition from his physical to spiritual body took place through a miraculous, simultaneous disintegration of every single particle in the body, which takes all those neutrons, protons, and deuterons and zooms them into the cloth, strengthening the cloth, turning the blood bright red, and all the positively charged protons and deuterons are hitting the very uppermost surface of the cloth. He's leaving us a picture of himself, a photographic, negative, perfect picture of the inside to the outside of his body with the very particles that constituted the body. At the same time the particle flows are going on, there's a big bright light with a big boom. And God is saying to the world of scientists who will be investigating this 2,000 years later, gotcha. I mean, an indisputed relic of the resurrection with the embodiment that moved from physical to a spiritual body, emblazoned on the shroud with perfect three-dimensional photographic negative image. This is just too good for words. Who's going to deny it if we find those cosmogenic isotopes in the shroud? All I can tell you is the resurrection is not so far from the realm of scientific evidence. Thanks so very much. Play video number 9 for the kids. They'll get what you just got. It'll stun them. It'll stun them.
Have the shroud of Turin been accepted by the Vatican?